So the purpose here is to see how we can recognize voices. As you can see, the red dot is recognizing when someone is speaking. And we can see also the audio going on. And the more I talk, the more my voice is being vectorized to a space where that makes sense for the machine. And we're trying to compress that to a two-dimensional space. And the more I talk, the more my features are going to be projected closer to each other. My dots are going to be projected closer to each other. And if Will starts talking, we're going to see his vectors being projected to a different space in the voice vector space.
Right, so if there's another person speaking, then the difference between my vectors and Dario's should be drastic enough to where it begins to cluster them into different regions of the same space. So we can begin to separate them, and the system can know that there are two people talking, not just one.
Exactly. We can see now that Will can be assigned eventually to person two probably because I talked for longer and the blue dots are the most. And as you can see, the more I talk, the more blue dots are going to be added to the vector space. And eventually, if you want to assign an identity to my face and to the voices, we just sort of draw a line between the two clusters. And we can go back to Will and you can see that more red dots are going to be added.
Right, and this happens automatically, so we don't need to have foreknowledge of a person's voice. The system can, in real time, be able to cluster into different voices without knowing how many people are there or who they are.
And a final note is that the vector space is multidimensional, so and it's easier when you have multiple features to divide to people. Now we are just compressing onto two dimensions, and it seems like they're very close to each other, but in a higher dimensional space, the difference is much bigger.